For this video, I'm going to focus on the shells method, but when we have a shifted vertical axis of rotation. I am assuming that you have already watched part 1 of the shells method series and part 2 of the shells method series, and we can go from there. So suppose we have two graphs. We have y equals x squared and we have y equals 2x. And their intersection forms this region here. And we're going to rotate it around the line x equals 3. And we're also going to use the shells method for this video. So we're going to draw a cross section parallel to the axis of rotation. That's for the shells method. And that width of that cross section is some tiny, tiny, arbitrarily small amount called dx. And we're going to rotate that cross section around the axis of rotation. And this gives us just a general idea. We just chose one random rectangle and one random cylinder, and this will help us set up a formula for the entire region. So next we're going to cut the cylinder and peel it out and get this rectangular slab as we had discussed in part 2 or maybe part 1 of the series. And we know we just need to find the volume of this rectangular slab. And so we have our width and our height, and the volume will just be the width times the height times dx. So now we only need to find r and the height. So let's first look at the height. So the height corresponds to this length right here. And so the height is going to be the top curve minus that bottom curve. That blue line corresponds to that distance. And so in this case, the height will be 2x minus x squared. And so now we need to find that radius. So here's 2 pi r on our rectangular slab. And we know from part 2 of the series that that corresponds to the circumference here on the cylinder. And our radius is right here. It's the radius of the circle on top of our cylinder. And so let's clean up and zoom in. And remember this r distance is going from our axis of rotation to our rectangle that we drew, our cross section. And so I just moved it around so that you can see that it does not go to the curve. And so this orange length here, that is equal to this blue length plus my radius. And so by reordering that equation around, we can see that the radius is just going to be the orange length minus the blue length. So let's find those lengths. The orange length is 3 because it is the distance from x equals 0 to x equals 3. And that blue length is just equal to x because it goes from the y-axis to the rectangle. So our radius is just 3 minus x. And we have our radius. And now our volume is also found because we have our height and our radius. So we can add this formula up on infinitely many rectangles, and we get the formula for our volume, our total volume, which is the definite integral. All right, and that's it. Thanks for watching, and I'll see you next time.